This is Marwa, and we are going to be discussing how to find the rational roots of a polynomial function using rational roots theorem. We already had 3 previous videos about polynomial functions where we discussed what are zeros and what are roots and multiplicity, how to find equations. We're gonna do more videos about polynomial functions, but all of them are about the theorems of finding roots of polynomial functions. This video is about the rational root theorem. Our next one is going to be about the conjugate root theorem, and the last one is going to be about the fundamental theorem of algebra. Now let's discuss how do we find rational roots. Now before we find rational roots, we just need to remember 2 things. What do I mean by rational numbers? That for a root to be rational, now roots are the zeros. They have the same meaning, and we discussed that before. You can go back to our videos to see why roots and zeros have the same meaning. But what do we mean by rational? A rational number is any number that can be written in the form of a over b, or can be written in the form of the fraction. That goes for whole numbers like 3, because 3 can be written as 3 over 1. Integers also, let's say -5, so that's -5 over 1. Or let's say 2 over 3, -1 over 5. All of these are considered rational numbers because they can be written in the form of a over b. What is not a rational number? Radicals that don't have a square root, like a perfect, that are not under the perfect square. Like this is the square root of 3. Now, square root of 3 is not a whole number. So this here is considered an irrational number. So this is not a rational root. I can't find that. Imaginary numbers as well, like 2i, that is not rational. So if I'm looking for rational roots, I am looking for numbers that can be written in the form of a fraction. Okay, now that has been discussed. Let's see what is the rational root theorem all about. Now the rational root theorem states that if any equation does have rational roots, because sometimes they don't, but if they do have rational roots, the rational root of this polynomial function has to be, if it's a fraction or even a whole number, its numerator is going to be a factor of the constant, and the constant in this case is 6, and the denominator for the root we are going to find is going to be a factor of the leading coefficient. Now what do I mean by leading coefficient? The number multiplied by the highest degree term we have. Okay, so let's see what are the factors of 6 here, or -6. Now it could be 1 times 6 or 2 times 3. However, both of them are positive and negative, because you can multiply -1 by -6 and still get 6. So all the possible factors of the constant are positive -1, positive -2, positive -3, and positive -6. Factors of the leading coefficient, which is 2, is positive -1 and positive -2 only. So if there is a rational root for this equation, this rational root has to be a fraction. Its numerator is a factor of the constant, and its denominator a factor of the leading coefficient. Now how do I find these? I believe there are too many of these. Let's make a table for them. Sorry for the line. And find out, test each one of them and tell whether it's a root or not. Now how I'm going to do that? I'm going to start dividing. Now I'm going to divide the numerator by the denominator. 1 divided by 1, that's a 1. So this is a possible root. Not for sure, but maybe. 1 divided by -1 is a -1. Then 1 divided by 2 is half. 1 divided by -2 is -half. So I have divided 1, the positive one, by all 4 roots I have in the, 4 factors I have in the denominator. What about -1? If I divide -1 by 1, I'll get -1, which I already have. If I divide -1 by -1, we'll get 1. It's already there. If I divide -1 by 2, I'll get -half, it's there. And if I divide -1 by -2, you will get half. So if I divide only the positive value here, but make sure I divide them by all positive and negative values, it's going to be the same when I divide the -1. So only divide the positive, just to save your time. Now I'm done with dividing 1, so I can just cross it out so I don't repeat any of the values. Now I'll start with dividing 2. 2 divided by 1, that's a 2. 2 divided by negative 1 is negative 2. 2 divided by 2 is 1. I already have it, don't write it again. 2 divided by negative 2 is negative 1. We already have it, so don't divide it again. So I'm done with the 2 as well. Let's start dividing the 3. 3 divided by 1 is 3. 3 divided by negative 1, that's a negative 3. 3 divided by 2 is 3 over 2. 3 divided by negative 2 is negative 3 over 2. And I'm done with the 3. Now let's look at 6. 6 divided by 1 is 6. 6 divided by negative 1 is negative 6. 6 divided by 2 is 3. I already have it, don't write it again. 6 divided by negative 2 is negative 3. Already have it, don't write it again. Now these are all the possible rational roots we have. These are all the rational numbers we can get by dividing the factors of the constant by the factors of the leading coefficient. Now, of course, not all of these are roots of the equation. We need to test them one by one to find out which of them is a root for this equation. How do we test them? We're going to test them by substituting in the equation we have. Now, if I substitute for x equal 1, I'll get p of 1, which is 2 multiplied by 1 cubed plus 1 squared minus 7 multiplied by 1 minus 6. Now, using your calculator, you will find that this value here is negative 10. Now, I'm sure now that 1 is not a root, because the value of y when x is equal to 1 is not 0. So this is not a root. I'm going to do the same thing for the next number we have, which is negative 1. And you're going to do the same by testing each of the possible roots you have. These are possible roots. I can't tell whether they're roots or not until I substitute in the equation and find out. When you substitute for x equal negative 1, your answer is going to be 0 using your calculator. So now I know for a fact that this is a rational root, okay? I can continue testing all of them to find whether they are zeros or not, and I'm going to do that in a minute. But before I do it, I want to show you an easier way to get the rest of the roots. Now that I have one of the roots, then I know one of my zeros is negative 1, right? One of my factors is x plus 1 for this equation. So this equation is basically equal to x plus 1 multiplied by something else, because this is the power of 3, so I should have 3 factors, and accordingly 3 zeros. We can test all different zeros to find the rest, or we can do a shorter way, which is by using synthetic division. Now I can use synthetic division. I'll divide by negative 1, which is the 0 I have, to reduce this equation from a cubic equation to a quadratic. So let me do that. I will write the coefficients of all terms, so that's 2, 1, negative 7, and negative 6. Start the division, you bring down the first term, you multiply. I'm sure you know how to do this. Negative 1 multiplied by 2 is negative 2. You add, you get negative 1, multiply again. We add, we get negative 6. Then we multiply negative 1 by negative 6, you get 6. You add, you get 0. Now, this is the remainder. This is your constant. This is the coefficient of x. This is the coefficient of x squared. So what I'm basically saying is that when I divided this polynomial function by negative 1, which is the 0, or by this factor, we got 2x squared, multiply the coefficient by the number, minus x minus 6 equal to 0. If you try to factor this, we get 2x multiplied by x, and the 6 is equal to 2 over 2 multiplied by 3. We're going to put the 2 here, negative, and the 3 here is positive. So other two zeros are x equal negative 3 over 2 and x equals to 2. Now, this took way less time than testing the rest of the zeros. So you can stop once you find one of the zeros, because this is a cubic function. Use synthetic division to reduce it into a quadratic function. And if you have a quadratic, you can factor it. If it cannot be factored, you can use the quadratic formula to find the factors. Now, if I want to check if my answer is correct, just go through filling the rest of the table. You can test -3/2 and you will get a 0. And you can test 2 and you will get a 0. The rest of the values are for half, -9. I found that after substitution, of course. For -half is -5/2. For -2, it's -4. For 3 is 36. For -3 is -30, so none of them is a 0, of course, or a root. For 3/2, it's -15/2. For 6, it's 420. And for -6, it's -360. So again, let's take a look at what we did here. We have used the rational root theorem, which states that if there is a rational root for a polynomial function, that root is going to be the quotient of dividing a factor of the constant by a factor of the leading coefficients. You find all factors of the constant, all factors of the leading coefficient. Divide them by each other, make a table, find all possible roots. One way to solve this is to test each of those possible roots, and once the ones you get zeros, then you know that these are the roots of the function. Okay? The ones you don't get zeros, you know these are not roots. Now, this is a cubic function. It has 3 zeros, and we found all 3 of them. This is one way to do it. Another way to do it, which would save your time, once you find the first 0, and it's a cubic function, you are going to use synthetic division. By dividing by that 0, you'll get a quadratic, factor the quadratic, you'll get the rest of the zeros. So this function here is equal to x plus 1 multiplied by 2x plus 3 multiplied by x minus 2. The roots are -1, -3/2, and -2. I hope this has been helpful and got you to understand what is meant by the rational roots theorem. In our next video, we will be discussing the conjugates roots theorem. Then we will discuss the fundamental theorem of algebra. Thank you so much for watching. I hope this has been helpful for you.